Okay, so we are back and we are going to be doing 7.2 Ready, Set, Go number 14, which the directions say use the given solutions. So these are solutions of a quadratic function and the y-intercept to find the original equation. So the way I want you to picture this is just all you're doing is you're going backwards. So my example that I gave you was like, hey, let's pretend that we had the solutions x is equal to 4 and x is equal to -2. Well, the picture of that looks like this. And then you can kind of see a parabola going through here or through here, right? Upside down or right side up. And then so what I want you to picture or imagine is that now you're just going backwards. So if x equals to 4 is the solution, do you remember how the line right before that was just your zero product property? And it said x minus 4 quantity times the quantity of x plus 2 equals to 0. And then from there, like now again, pretend that we're moving forward, you would just separate each piece and set it equal to 0 and then solve. And so that's how you actually get the solution. So all we're going to do, excuse me, is we're just going to go backwards, right? We're going to take each step. And then from here, all you're going to do is just multiply. And then you're pretty much done. So I'm going to do this work down here because there's enough space. And Miss Johnson, she writes big. So you know what that means. Okay, so I'm going to write these separate. So it says x is equal to -5 plus 5i root 2. And x is equal to -5 minus 5i root 2. And the y-intercept is going to be 0, 75. Okay, and all of these numbers actually make sense for us to put together. So the very first thing that I'm going to do is I am going to write out, if these are the zeros, then I'm going to write out the factors. And the way I get the factors, it's literally the line above this that got me this, and I set it equal to 0. So just to help you imagine, I'm going to put this equal to 0 here and equal to 0 here. And I almost want you, and this sounds weird, but I want you to solve these equations for 0. Not for x is equal to 0, for 0. Meaning I want to move all of this -5 stuff to the x side, and then that plus 5i root 2 to the left-hand side. Okay, so how do you do that? Well, you just add 5 and you subtract 5i root 2. So then you get x plus 5 minus 5i root 2. So this is one of the factors, right? This is one of the factors. I'm going to go grab the other factor by doing the same thing. Actually, can you practice that? Can you practice moving all of the stuff on the right-hand side of that equation to the left-hand side, therefore solving for 0? Go ahead and do that. Okay. While you're doing that, I just want to remind you that square roots, if you think about how you actually get a square root, you've taken the square root of something. And then whenever you take the square root, you always get plus or minus. So these guys, these radicals and the i's, they travel in their conjugate pairs. And if you remember what a conjugate is you see the same numbers, -5, -5, you see 5i root 2, you see 5i root 2, and then you see a plus here but a minus here. So that's what a conjugate is. The numbers are the same, but the operation between them are different. Okay, so I got x plus 5 plus 5i root 2. Hopefully that's what you got too. And if you can imagine, the line before that would be these two factors multiplied together set equal to 0. So I'm going to write that down. So x plus 5 minus 5i root 2, x plus 5 plus 5i root 2 equals to 0. Okay, so with that being said, what are you going to do now? Like, what is it actually telling you to do? What do you think? What is this thing telling you to do right now? Okay. Yeah, you multiply them. So I'm just going to multiply these two. And the way I multiply is I make a gigantic box. And this is the area model for those of you who are familiar with the area model. Just kind of be a little bit on the neat side because you got to squish people in there. So x5 negative 5I root 2. Okay. So x times x is x squared. 5 times x is 5x. 5I root 2 times x. Now just keep this right. It's 5xi root 2. Now some of you are like, but Miss Johnson, I put the x after the I. That's fine. As long as everybody who's outside that square root is outside and everybody's inside is inside, you're fine. Okay. And then I'm just going to continue. So I get 5x, I get 25, I get 25I root 2. So here I get negative 5xi root 2. I get negative 25I root 2. And then lastly, I get negative 5 times 5 is negative 25. I get I times I, which is I squared. I get root 2 times root 2, which is root 4, which is really, root 4, which is really 2. So this is a 2. And if you remember what I squared is, I squared equals negative 1 because I equals the square root of negative 1. And these are definitions that you just kind of have to memorize. Okay, so this is negative 1. And then this is negative 25. And then I just multiply. So negative 25 times negative 1 is 25 times 2 is 50. Right? And let's see, I got negative 25I squared plus 25I squared. Those cancel. Negative 5xi root 2 and positive 5xi root 2 cancel. Okay, and then so here I'm just going to add like terms. I get x squared plus 10x plus 25 plus 50, which is x squared plus 10x plus 75. Okay. And then all I do is I just make sure that when I plug in 0, I actually get out 75. So when I plug in 0, yeah, I get 75. So here's my function, and that's pretty much it. Yeah. So that's actually it. F of x equals to x squared plus 10x plus 75. And the way you check this one is because they made you go backwards, now you can go forwards. You can factor this thing, or not factor. You can solve this thing and see if you get those two as your solutions, right? Okay, so now looking at this thing, none of the steps individually are like, what did you just do? But all of them collectively are kind of like, wow, that's a lot of work. So just remember, you're just going backwards from solution to factor and from factor to multiplying. And then once you multiply, then that's actually your answer down here, which is your polynomial. So do you have any questions on here? Do you have any questions on here? All right, very good.